Good morning, my dear students. In this video, I will explain state space analysis in control system. Before going to state space analysis, what are the previous methods to analyze the control systems? What are the drawbacks in previous methods? And what are the advantages by using this state space analysis? We will discuss. So initially, what are the previous methods to analyze the control systems? Previously, we are having two different methods to analyze the control systems. One is time domain analysis. Second one is frequency domain analysis. What are the drawbacks in these methods? The first drawback in previous methods, that are time domain and frequency domain methods, is it is not very much convenient for the analysis of multiple input and multiple output systems. That is the first drawback. If the given control system is multiple input and multiple output system, the previous methods are not suitable for analyze the control system. And second drawback, it gives analysis of the system for some specific type of inputs like step ramp. That means if the control system having standard inputs, then only we can analyze the system by using time domain and frequency domain. If the inputs are not standard like step ramp, the time domain and frequency domain methods are not suitable for analyzing the given control system. Next drawback is it is only applicable to linear time invariant systems. Linear time invariant systems. If the system is linear time variant system, the previous methods are not suitable, and the methods is insufficient and troublesome to give complete time domain solution of highest order system. That means if a given control system is highest order or higher order system, then also the previous methods are not suitable to analyze the control system. These are the major drawbacks in the previous methods, that are time domain analysis and frequency domain analysis. So to overcome these methods drawbacks, we can go for the another method, that is state space analysis. The modern method discussed in this chapter uses the concept of the total internal state of the system, considering all initial conditions. That is the meaning of state space analysis. The technique which uses the concept of the state is called state variable analysis or state space analysis. So in state space analysis, we can consider the total internal state of the system and considering all initial conditions, so that this is very effective and having some advantages than compared to the previous methods. Finally, what are the advantages of this state space analysis? Advantages of state variable analysis or state space analysis. The first advantage is the method takes into account of effect of all initial conditions, so that it gives the analysis for all initial conditions. That is the first advantage. Second advantage, it can be applied to non-linear as well as time varying systems. That is the second advantage. Next, third advantage is it can be conveniently applied to multiple input and multiple output system. But previous methods are not suitable for multiple input and multiple output systems. Next advantage is any type of the input can be considered for designing of the system, so that the previous methods are not suitable for any type of input. The previous methods are suitable only for standard type of inputs like step ramp, but this method is very convenient for any type of input. Next advantage, as the method involves the matrix algebra, can be conveniently adopted for the digital computers. Nowadays, in all sectors, we are using the computers. The computers are very well known about the matrix format. So this state space analysis gives the matrix algebraic formats. It is very easy to understand by the system. These are the advantages of the present method, that is state space analysis. Up to now, we know what are the drawbacks in previous methods and what are the advantages in this method. And we want to analyze the system by using the state space analysis. Some basic definitions are required. So what are the basic definitions? That are, first one is state. What is the state of a given system? So this is the meaning of state. The state of a dynamic system is defined as a minimal set of variables such that the knowledge of these variables at t is equal to t0 together with the knowledge of the inputs for t greater than or equal to t0 completely determines the behavior of the system for t greater than t0. So that is the meaning of state. So the simple meaning of this statement is the dynamic system is defined as, the state of the dynamic system is defined as the minimum set of variables at t is equal to t0 together gives a complete behavior for t greater than or equal to t0. So then the state is called as state of that particular dynamic system. Next requirement is state variables. The variables involved in determining the state of a dynamic system x of t are called as state variables. That is, the state variables which are included in the state developed for a digital or dynamic system is called as state variables, that are x1 of t, x2 of t, and so on xn of t. These are the representations of state variables. The next requirement is state vector. The n state variables necessarily to describe the complete behavior of the system can be considered as n components of the vectors x of t, called the state vector at a time t. The state vector x of t is the vector sum of all the state variables. That means the state vector is n state variables necessarily to describe the complete behavior of the system. To describe the total behavior of the system, n state variables are required. Combine these n state variables as the vector form is called as state vector. Next requirement is state space. If you know the meaning of this state space, we can see this diagram. The space between x and y coordinates. x1 of t is one state variable, x2 of t is one state variable. The space between these two state variables is called as state space. The next requirement is state trajectory. It is the locus of the tips of the state vectors with the time as the implicit variable. So x1 of t, x2 of t, two state variables having the state vectors like this. This one is x of t1 variable having the vector. This one is x of t2 vector. The tips of these two vectors combined together by a vector is called as state trajectory.